A pole staying 75 feet tall. An angle theta is formed when wires of various lengths of x, and this is in feet, are attached from the ground up to the top of the pole, as shown in this figure. We want to find the rate of change of the angle, which is our d theta dx. And we want to find that when the wire is 104 feet. So we first need to set up a formula or an equation for theta, so then we can take the derivative. So we're going to go back and use our formula right here for the inverse of sine. This is what we're going to need to do it. And we're going to set up this equation first using our knowledge of triangles. So I have that the sine of the angle is opposite over the hypotenuse. So I'm looking at the opposite side over the hypotenuse. Since the opposite side is 75 and the hypotenuse we have labeled as x, I'm going to set up my equation as sine of theta is equal to 75 over x. Then I'm going to rewrite this equation, sine theta is equal to 75 over x, in terms of theta right here, so that I can find the derivative. So when I rewrite the equation, I have theta, our angle, is equal to the inverse sine of 75 over x. So now I can use this formula up here for the derivative for the inverse of sine, and use that to find the derivative of theta. So when I find the derivative of theta with respect to x, using this formula up here, I have 1 over the square root of 1 minus, and then the we're going to use substitution here. Since we have our inner function is 75 over x, that's what I have to put in here for this x here. So I have 1 over the square root of 1 minus 75 over x quantity squared. But then because I have something other than x in there, I have to use the chain rule and multiply by the derivative of 75 over x, which will give me this. So I got this negative 75 over x squared by using the chain rule. Now, when we clean it up and I multiply across the top and across the bottom, I get that the derivative of theta with respect to x is negative 75 over, and then in the denominator, I have x squared times the square root of 1 minus 75 over x quantity squared. Now I just have to evaluate that at 104. So on the calculator, I'm going to plug in 104 everywhere I see x, making sure that I put parentheses in the denominator so the calculator understands the order of operations. So I want the calculator to know that that 104 squared and the square root is in the denominator. Okay, when you put all of that in your calculator and you round to 5 decimal places as the question requests, you should get negative 0.01001.